Pat, how many nodes?
2.
2. How many antinodes?
1.
1. Now, if I go like, hold on, that, now what's happened to the wavelength? Wavelength is now the distance between Preston and I, right? Okay. How many nodes?
3.
3. How many antinodes?
2.
2. Now, if I go even faster, something like this, okay? That's got to do. How many antinodes?
3.
3. How many nodes do you have?
4.
4. So, what do you know? Let go. What do you know? What do you notice about the number of nodes relative to the number of antinodes?
There's one more.
Which one's always bigger?
Greater than
One bigger.
crazy.
Crazy.
You know what they don't. That Mountain Dew.
Code red, code red, code red, code red. Coke, Dr. Pepper, Dr. Pepper, Coke, Dr. Pepper, Coke, cheers. Yeah, good day.
Such a shame that they removed
I think
the
Coke is
actual
much more refreshing
ingredient.
than Dr. Pepper.
I know, right?
Well,
If they just made Coke the old way.
The FBI director at the time.
If they just make Coca-Cola how they used to.
Oh yeah,
It'd be great.
at the time treated it like caffeine like a video game, which I mean,
I got stuff.
Chocolate bar monkey. He's very addicted to caffeine.
Did you have stuff?
Now, I gotta go old school. Hold on.
Can you spell it? No, you can't.
you should say that's like honor
Are you gonna do
Oh my god, that's old.
Yeah, this is old school here.
Yeah, this is one of those old things. This is the one you use like the wax things on.
Yeah. Now, when I started teaching, this was high tech. So,
I mean,
if you had one of those, you could do overheads, and I mean, this was cool if you had this.
I mean, it still is.
So a lot of times, what happens is that you have waves that run into each other. So this is what I'm going to try and show with this. So. Imagine that you have one wave going in one direction, which is tough to do because you're like seeing it backwards. Okay? So imagine that you have two wave fronts that are moving in opposite direction. Now, as those two begin to interact, okay? As you get like this, what do you think is going to happen to the energy because they're on opposite sides?
They'll cancel each other out.
They're going to cancel each other out. So at this point where these are completely overlapped like this, okay? So what would happen, give me a second. This is why I hate overheads. So at this point, you have a peak up there at the top, and you have a peak down there at the bottom. So effectively what would happen is that those two energies would cancel each other out. So what would happen is that nothing. So there would be, in effect, be no wave. You have one energy that's completely on one side, you have an equal amount of energy on the other, so what would happen is that these would cancel each other out. Now, if you flipped it though, and you had a situation where the energy was both on the same side, then what would happen?
Double.
Then it would be an additive property. Okay? So that's what happens when that sound gets really, really loud. So when that sound gets really, really loud, what's happening is that those wave fronts are basically in phase with each other. So one is matching one at the exact point that the other one is going past it. They're in phase, they reinforce each other, and it gets really, really loud. So, but the opposite happens though. So this is the difference between what you call destructive interference and constructive interference. So this is an example of constructive interference. You always get constructive interference when both wave fronts are on the same side. You get destructive interference when the wave fronts are on opposite sides. Okay? So what would happen is that these would go past each other. So at this point, right? So now you would actually have two different waves completely canceling each other out. You would have one up there on the top, one down there on the bottom, but then as they go past, then the beauty of this, once they go past each other, then they have like a memory, and they go back to the waves like they were at the beginning. So you only get that constructive and destructive interference when those waves are interacting. Got the visual. So basically, you either add them or you subtract them, depending upon which side of that wavefront that you're on. Okay. I'm dying. Let me see. So, a couple of things to finish up.
Yes.
You say Giga What?
No.
I heard Giga.
What?
I said bro.
I heard Giga.
Well, yes, apparently that's a slur now.
Oh, boy.
Yeah, obviously.
Yeah.
Yeah. Chris Graham was talking about
Wait. Oh, so just the radius.
Okay, so here's what you're going to be dealing with, and the same thing is going to be true of the lab on Monday. So you're going to have two different extremes. You're going to have what we call an open system. And again, we represent these as transverse waves. In reality, they're not, but it makes the visual on the math work out better. So if it's an open system, okay, like a flute or something like that, then when you hit that point of resonance, that distance there is representing half the wavelength, okay? In contrast, if you have an open-closed system, which is like that tube where it bounces off the water, then that distance is 1/4 of the wavelength. So to get the wavelength here, you multiply that by 4, okay? Those are going to be two extremes. That's what we're going to look at in terms of the lab on Monday. Couple of housekeeping things. And I've talked to my AP chemistry kids about this. So for February 20th, Mays Elementary is having like a family night, open house kind of thing. And I always go over and help them out and kind of do some science for little kids. It's like 5:30 to 7. So would any of you be interested in, if you need like volunteer hours for NHS, where we could go over and set up, like I do a show and then kind of turn the kids loose with maybe some magnets and some physics experiments. And so who would be interested in kind of helping out?
What day is it?
February 20th. February 20th. Okay, that'll give me a good number. Okay. Also, listen to me so I do not get yelled at. If you've been sent an email, okay? If you have not gone through that AP chemistry through the College Board's joint code, do that, or I get yelled at. And quite frankly, I don't have the tolerance right now to get yelled at by a former student of mine. So right now, if you have not, there's an email that was sent to you. There's a link. You click on it. It's not rocket science.
How do you know?
Also,
It is for code.
for those of you that are interested in taking this class for dual credit, they will be here on Monday to kind of give you the very short version. It's the exact same process as what it was last year or last fall, okay? Same price, everything's the same. If you've taken it before, you're already registered. Should be a pretty simple gig, so they're going to be here on Monday, and that deadline to enroll is February, I think, 11th. Okay, so we still have time, but they're going to be here on Monday. Again, if you know you're going into engineering, do not take this class for dual credit. It won't count for the engineering, for the calculus-based physics, but it'll count for everything else. Okay. So this is actually out of chapter 16.
Does that not say first name?
That's a wavelength that Charles is making fun of me because of things I can't read.
I have an idea. We dig a pit and throw them in it and see who comes out. Exactly.
You're not making, I'm sorry.
Well, just Charles and Cohen.
No,
Hunger Games type of thing. Say that louder for the camera.
Wait, are we done?
I'm done.
For the record, Mitchell just
Let
said.
that be it. That's not, no.
Oh, I said Piobs. Which doesn't make any sense. Piobs. Send that to me.
Tyler sends it to the Discord.
Thanks, Tyler, for being useful.
How you
That
send it
sounded
to
way more condescending than I meant it to.
Okay. When you get to 26, it's a open closed system, and this will make sense. It's going to talk about harmonics. So on 26, when it's an open closed system, your harmonics occur on odd numbers, like 1, 3, 5. So what that means is like when you find that first wavelength, when you get that standing pattern, the next one will occur at 3 times that length. The next one will occur at 5 times that length. Now, they obviously get harder and harder to hear because you're making more and more of that column vibrate. So the loudest, most intense one is when you have that first harmonic. The second loudest is 3. Now, if it's an open system, that goes on all of them, like 1, 2, 3, 4. It's only the open closed system where it goes on the odd numbers. It'll make sense when you get to the problem, okay? Sorry about my horrible voice, but I'm done.
machine.